Electronic configuration. Electronic configuration. From quantum numbers, we are able to know that around the nucleus, this is the nucleus, around the nucleus, there are certain energy levels, which we call as the main energy level. And these energy levels are denoted with small n. This is the first energy level from the nucleus, so its n is equal to 1. Its n value is 1. And this is the second energy level from the nucleus, so its n is equal to 2. Then this is the third one from the nucleus, n is equal to 3. N is equal to 4. N is equal to 5, and so on. So these are the main energy levels. From the nucleus side, their n values are 1, 2, 3, 4, 5, so on. Now, according to the azimuthal quantum number or angular quantum number, angular momentum quantum number, each main energy level will have certain sub-energy levels. And the number of sub-energy levels that were present in each main energy level are equal to their n value. So here, for n is equal to 1, only one sub-energy level is there. For n is equal to 2, we have two sub-energy levels. For n is equal to 3, we have three sub-energy levels. For n is equal to 4, we have four sub-energy levels. For n is equal to 5, we have five sub-energy levels, and so on. So, the values of these sub-energy levels are denoted with small l. So, in the first main energy level, we have one sub-energy level. Its L value is 0. Here, its L value is 0 and this L value is 1. Here, we have three sub-energy levels. Their L values are L is equal to 0, L is equal to 1, L is equal to 2. Similarly, in fourth energy level, we have four sub-energy level. L is equal to 0, L is equal to 1, L is equal to 2, L is equal to 3. That means the L values are from 0 to n minus 1. The minimum L value is 0. The maximum L value is n minus 1. That means if in fourth energy level, L values are from 0 to 3. In second energy level, L values are from 0 to 1. In first energy level, L value is 0. In fifth energy level, L values are from 0 to 4. In sixth energy level, L values are 0 to 5. In seventh energy level, L values are 0 to 6, and so on. When L is equal to 0, it is called as S sub-energy level, S sub-energy level, S sub-energy level, S sub-energy level. Its n value is 1, so we call it as 1s, 2s, 3s, 4s, 5s, 6s, 7s, and so on. If L is equal to 1, then it is called as P sub-energy level. 2p, 3p, 4p, 5p, 6p, 7p, and so on. So P is the sub-energy level. If L is equal to 1, here this is also P and this is also P. If L is equal to 2, it is called as D. So 3D, 4D, 5D, 6D, 7D, and so on. Similarly, if L is equal to 3, it is called as F. 4f, 5f, 6f, and so on. Remember, the L value must be n minus 1. That means in second energy level, you will not have L is equal to 2. In third energy level, you will not have L is equal to 3. In fourth energy level, you will not find L is equal to 4. Because maximum L value is n minus 1. That's why L is equal to 1 starts from second energy level. L is equal to 2, that is d orbital, starts from third energy level. L is equal to 3, that is F sub energy level, it starts from fourth main energy level, and so on. In first energy level, we have only one sub energy level, that is 1s. 1p is not there. In second energy level, you have 2s and 2p. There is no 2d, because L value must be n minus 1. So these are generally we call orbitals, but they are not orbitals. We should call them as sub-energy level, S sub-energy level, P sub-energy level, D sub-energy level, F sub-energy level. Orbital is a different word with a different meaning. Now, in each sub-energy level, there are some orbitals with the same energy. In each sub-energy level, there are certain orbitals with the same energy. That's why we are not getting further fine lines, because their energy is same. But each electron, since it is acting as a magnet itself in its circular orbit when it is moving, if these electrons are under the influence of magnetic field or electric field, they were reflected. Because of their reflection under the magnetic or electric fields, separate lines or splitting of lines were observed in the spectra. Those splittings are said to be splitting of spectral line. They are familiarly known as Zeeman effect and Stark effects. So this Zeeman effect and Stark effects will give us the number of orbitals that were present in each sub-energy level. So the number of orbitals that were present in each sub-energy level will be equal to 2L plus 1. So the number of orbitals that were present in a given sub-energy level will depend upon its 2L plus L value. For example, S sub-energy level. S sub-energy level. For S sub-energy level, L is equal to 0. For S sub-energy level, L is equal to 0. So the number of orbitals present here will be equal to 2L plus 1. They are 2 into 0 plus 1. That is only one sub-energy level is there. And its value is denoted with M, and its M is equal to 0. Similarly, for P sub-energy level, L is equal to 1. So the number of orbitals that are present in P sub-energy level are equal to 2 into 1 plus 1, that is equal to 3. So there are 3 orbitals in a given sub-energy level, P sub-energy level. And these 3 orbitals will have 3 different M values. They are M is equal to minus 1, M is equal to plus 1, M is equal to 0. Similarly, if D sub-energy is there, L is equal to 2. So the number of orbitals present in D sub-energy level are equal to 2 into 2 plus 1, that is 5. So it has 5 M values. There are 5 D orbitals in D sub-energy level with 5 M values. They are M is equal to minus 2, M is equal to minus 1, m is equal plus 2, m is equal plus 1, and m is equal 0. These are the 5 orbitals that were present in d subenergy level. Similarly, for F subenergy level, L is equal to 3. So there are 2 into 3 plus 1 is equal to 7. There are 7 orbitals, there are 7 F orbitals that were present in each F subenergy level, and they have 7 M values. Those 7 M values are M is equal to minus 3, M is equal to minus 2, M is equal to minus 1, M is equal to plus 3, M is equal to plus 2, M is equal to plus 1, total 6, plus M is equal to 0. So here we have a definite number of orbitals in each subenergy levels. That means in all S, L is equal to 0, S subenergy, we have only one orbital, whether it is 1s or 2s or 3s or 4s. Whatever the n value it may be, all S subenergy levels will have only one orbital. If L value is 1, that we call it as a P subenergy level. In P subenergy level, we have 2L plus 1, that is 3 orbitals. They are like this. Three subenergy levels. And their values are minus 1, 0, plus 1. Minus 1, 0, plus 1. Minus 1, 0, plus 1. Generally, they are designated as Px, Py, Pz. By default, M values for Pz orbital are called as 0. For Pz, it is 0. For Px and Py, they may be plus 1 or minus 1. So, the 2p orbital, whether it is 3p orbital, or it may be 4p or 5p or 6p, whatever the n value it may be, all p subenergy levels will have 3 orbitals, and their m values are minus 1, plus 1 and 0. Minus 1, plus 1 and 0. L values are from minus L to plus L, including 0. Now, if you take D subenergy level, its L value is 2. So, the maximum number of orbitals that can present in that subenergy level are equal to 2L plus 1, that is 2 into 2 plus 1, that is 5. So, in D subenergy level, we have 5 orbitals. 1, 2, 3, 4, 5. And each orbital will have a different M values. The M values are minus 2, minus 1, 0, plus 1, plus 2. Minus 2, minus 1, 0, plus 1, and plus 2. Whether it is 3D orbital, 4D orbital, or 5D orbital. 3D subenergy level, 4D subenergy level, or 5D subenergy level. It will have 5 orbitals with 5 M values, and those M values are from minus 2 to plus 2, including 0. Minus 2 to plus 2, including 0. Similarly, F subenergy level will have 7 orbitals. F L value is 3. 2L plus 1. 2 into 3 plus 1. 2 3s are 6, 6 plus 1, 7. So there are 7 orbitals in F sub-energy level. And their values 1, 2, 3, 4, 5, 6, 7. And their M values are minus 3, minus 2, minus 1, 0, plus 1, plus 2, and plus 3. M values are like that. So this is the scenario. In fifth energy level, similarly we have 5 sub-energy levels. Now, when electrons are entering here in these orbitals, they will follow certain rules while filling up of these orbitals. So, the filling of electrons in different atomic orbitals, or the arrangement of electrons in different atomic orbitals, is called as electronic configuration. The arrangement of the electrons present in an atom in different atomic orbitals is known as electronic configuration. Electronic configuration means the arrangement or filling up of electrons in different atomic orbitals in an atom is known as electronic configuration. The electronic configuration or filling up of electrons in different atomic orbitals are governed by certain rules. They should follow certain rules. Now let us discuss those rules which guide the filling up of these electrons, or by which the filling up of electrons were followed. Those rules are, number 1 is Auf-bau principle. Auf-bau principle. Number 2, Hund's rule. Number 3, Pauli's principle. These are the 3 important rules that were followed in filling up of different atomic orbitals. First one is Auf-bau principle. Auf-bau principle. Auf-bau means building up of electrons or filling up of electrons. When electrons are entered into different atomic orbitals, the electron will enter first into the orbital which energy is relatively less. All orbitals are available for electron, because if you take hydrogen, only one electron is there, but in hydrogen atom you have not only first energy level, in hydrogen atom you have first energy level, second energy level, third energy level, fourth energy level, and so on up to infinity. And each energy level there are all orbitals. In first energy level you have 1s, in second energy level you have 2s and 2p, in third energy level you have 3s, 3p, 3d, fourth energy level you have 4s, 4p, 4d, 5f. So though it has only one electron, that small atom will also have all these orbitals. That was proved by the hydrogen spectrum. So in all these available orbitals, that first electron should first enter into the orbital with the least energy. That is Auf-bau principle. Auf-bau principle gives us that in the available orbitals, the orbital with least energy will be filled first. In the available orbitals, the orbital with least energy will be filled first. That is Auf-bau principle. That means 1s orbital is filled first. Then 2s orbital. Then here both 2p and 3s will have same n plus L value. In such cases, the orbital with the least n value will be considered as least energy orbital. So for 2p and 3s, n plus L value is 3, but n value is 2 for this and n value is 3 for this. So this is said to be least energy orbital. So then it is 2p. Then 3s. 3s. Then 4. Here also you have two orbitals with same n plus L value. 3p and 4s. So here also we have to follow the same rule. N value is 3 here, here it is 4. So 3p orbital will be filled first. Then we have 3d orbital. But 3d orbital n plus L value is 5. But 4s is 4. So first 4s orbital is filled. Then 3d. Though its n value is less. 3d n plus L value is 5. That's why 4s is filled first, then 3d. After filling of 4s only, the electron will enter into 3d orbital. Just like the remaining orbitals will also be filled like this. So to identify these relative energies, you need not calculate all n plus L values like this. There is a simple technique to remember the relative energies of different atomic orbitals. That technique was given by Moyle's energy diagram. Moyle's energy diagram. Moyle's energy diagram will give us a clear picture regarding the relative energies of different atomic orbitals. And observe how I am writing this energy level, because if you observe the way I am writing, it is easy for you to reproduce. So here in first energy level we have only 1s orbital, so 1s. In second energy level we have 2s sub-energy, 2s and 2p. You write like that, just like this. In third energy level we have 3s, 3p, 3d. In fourth energy level we have 4s, 4p, 4d, 4f. In fifth energy level we have 5s, 5p, 5d, 5f. In sixth energy level we have 6s, 6p, 6d. In seventh energy level we have 7s, 7p. And in eighth we have 8s. But here in sixth energy level we have 6 sub-energy levels, 6f and 6g. And here also 7d, 7g, 7f, 7g, 7h also present. But the atoms which so far discovered, there is no need to enter into these orbitals. That's why I am not mentioning that orbitals. These orbitals are sufficient for the present atoms up to 160. All atoms' electronic configuration will be within these orbitals. That's why I am not writing all those orbitals. Fn, 4f and 5f only filled, not the 6f. Similarly, there is no space for 7d. That's why I am not writing all those orbitals. Now, electrons first enter here, 1s. That is That is the orbital to be filled first. Next, in the second stage, electron will enter into 2s. After filling of this 2s, then electron will enter into 2p orbital, then 3s. After filling 3s, the electron will enter into 3p, then 4s. After filling 4s, electron will enter into 3d, then 4p, then 5s. Similarly, then 4d, 5p, 6s, then 4f, 5d, 6p, then 7s. After 7s, 5f, then 6d, then 7p. There ends the atoms. Though, suppose if you write here 8s, there is no need for even 8s also. That's why I am not writing. Or if you want, you can write it. But there is no need for this orbital. All these orbitals are sufficient for even for the element with 116 atomic number. So this is the way in which the different orbitals of an atom are filled. In this sequential order only, the electrons will be filled in different atomic orbitals. You can verify these values with their n plus L values also. You will get the same order. 1s, then 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, 4f, 5d, 6p, 7s, 5f, 6d, 7p, and so on. This is regarding Auf-bau principle. Auf-bau principle means building up of electrons. When electrons are entered into different atomic orbitals, the orbital with least energy will be filled first. The orbital with least energy will be filled first.